Boyle's law states that pressure is inversely proportional to volume at a constant temperature. This is discovered by Robert Boyle, the first modern chemist and therefore one of the founders of modern chemistry and one of the pioneers of modern experimental scientific method. Diving ketchup experiment. Prepare the materials needed. Clear soda bottle, packet of ketchup and water. For the procedures, first fill the bottle with water up to the brim. Then put the ketchup into the bottle. You can now compress the bottle using both hands, and then observe. It is visible that the sachet of ketchup sinks to the bottom and floats to the top when the pressure is decreased. Here is the scientific explanation. Since air gets compressed before water, the sachet of ketchup's volume decreases when the pressure on the bottle is applied. The density then increases, which makes the sachet of ketchup sink. Releasing the pressure increases the volume, and so the density decreases. This makes the sachet of ketchup float. The conclusion is, when the pressure applied by the hand increases, the volume of the sachet decreases. The Avogadro's law states that equal volume of all gases with the same temperature and pressure have the same number of molecules. Contributed Amedeo Carlo Avogadro, an Italian scientist. Soda-Mentos experiment. Prepare the materials needed. Bottle of Coke Zero, balloon, 3 pieces Mentos candy. For the procedures, put 3 pieces Mentos candy inside the balloon. And then, attach balloon-filled Mentos in a freshly opened soda. Now, drop the Mentos to the soda. Here's the scientific explanation. The carbon dioxide trapped in water molecules of the soda is released when Mentos dropped and disrupting them, which end up inflating the balloon. The porous surface of the Mentos together with its ingredients made a bubble form. This happens mostly because of nucleation, wherein the carbon dioxide of the soda is attracted to the Mentos. The reaction that happens between them is now called soda geyser. The conclusion is all bottled sodas have pressure so that more carbon dioxide can be forced into the solution. Opening the bottle releases the pressure, forcing CO2 out and creates some bubbles. The Mentos then acts as surfactant to the soda, which results to geyser. Gay-Lussac's law states that pressure is directly proportional to temperature at a constant volume. This is discovered by Joseph Louis Gay-Lussac, a French chemist and physicist. Egg in the bottle. Prepare the materials needed. Hard-boiled egg, earthenware flask, crucible tongs, matches, cotton ball, ethyl alcohol, evaporating dish. For the procedures, squirt some alcohol to the cotton ball on the evaporating dish. While using crucible tongs, light the cotton ball using matches. Then drop it in the flask. Put the hard-boiled egg on top of the flask and observe. The egg got inside the bottle. Here's the scientific explanation. Once the heat escapes from inside the flask, the temperature inside lowers, so there will be a drop in temperature according to Gay-Lussac. The egg will then be pushed by the greater pressure of the outside of the bottle and then gravity occurs. The conclusion is there will be more pressure outside the flask since the air inside is cooler, and this pushes the egg inside. The cooler the temperature, the lesser the pressure. Combined gas law states that pressure is directly proportional to temperature at a constant volume. This is the combination of Boyle's law, Charles' law, and Gay-Lussac's law. Water vacuum. Prepare the materials needed. Colored water, birthday candle, heirloom mirror flask, petri dish, and matches. For the procedures, place and secure the candle at the center of the dish. Now, fill the dish with colored water, and then light the candle. Cover the candle with an heirloom mirror flask, and then observe. For the scientific explanation, the lighted candle heats the air, expanding it and keeps the water level down momentarily. To keep burning, it needs oxygen, so it keeps on sucking from the heat. The air inside gets cooler because the oxygen starts depleting. Cooler air takes up less space, so there is lower pressure in the container, resulting to the liquid getting inside the flask and rise. Conclusion is, the heat from the candle makes the air expand, which forbids the water from getting inside. Later on, because of lack of oxygen, the air gets cooler, lowering the pressure and allows the water to rise inside. Charles' law states that volume is directly proportional to temperature at a constant pressure. This was discovered by Jacques Alexander César Charles, a French inventor, scientist, mathematician, and balloonist. Self-inflating and deflating balloon. Prepare the materials needed. Soda bottle, balloon, container with hot water, container with ice-cold water. For the procedures, securely place the balloon in the mouth of the bottle. Now, put the bottle with balloon to the container with hot water, and then observe. It made the balloon inflate. Now, put the bottle with balloon to the container with ice-cold water, and then observe. You can see that the balloon starts deflating. Here's the scientific explanation. Convection happens here. When the bottle was heated, the air molecules expanded and rise to the balloon, filling a larger space. Removing the heat made the air molecules get closer together, taking up less space, so the balloon deflated. The conclusion is, when the gas absorbs heat, the rate of molecular motion increases. On the other hand, when the temperature is cold, the rate of molecular motion decreases. Ideal gas law describes the relationship of measurable properties of ideal gas. This is discovered by Benoit Paul Emile Clapeyron, a physicist and engineer. Shrinking plastic bottle. Prepare the materials needed. Hot water, plastic bottle, basin with cubes. For the procedures, fill the bottle with 50 ml hot water. And then, shake the bottle to spread the heat. Remove the hot water and immediately cover the bottle. Let the bottle stand in the basin with ice cubes. And observe. Here's the scientific explanation. PV is equal to nRT. If right side decreases, the left side shall grow. The right part of equation decreased. The N decreases as the water vapor condenses into liquid. R is constant. The T changed because the bottle, which is hot from hot water, got cold when placed in ice cold water. The left part of equation decreased. The P dropped because molecules move slowly when the T is low, and thus it bounces on the sides of the bottle lesser. The V drops for the pressure inside the bottle is so low that the pressure outside crushed it. The conclusion is, due to the change in temperature from hot to cold, the pressure dropped and made the molecules move slowly, which also results in crushing of outside pressure to the bottle. Juliana Ysabel Buenconsejo, Victor Felix Castelo, Hazel Rodriguez, Moriah Jasmine Yap.